My name is Derek Logan. I'm an associate professor at the Department of Biochemistry and Structural Biology at Lund University. And I'm a relative newcomer to the field of neutron macromolecular crystallography. We started doing it only 7 years ago in 2012. And it's been a great adventure for us, learning this technique, which is very similar in some ways to macromolecular X-ray crystallography, which I'd been doing for almost 30 years since I was a PhD student, and neutron macromolecular crystallography. The techniques are very similar but different in very subtle ways, and the sources that you use are different. The size of the samples you have to make is dramatically different. So learning the hurdles that you have to overcome and overcoming them eventually was a relatively slow process, but it has now resulted in 3 of the 160 to date crystal structures done with neutrons, which are deposited in the protein data bank. And these crystal structures are of a protein called galectin-3, which is a medically very important protein, and it's quite a hot drug target. And one of the characteristics of this protein is that its natural ligands and all of the synthetic inhibitors which have been designed as drug candidates to inhibit the interactions of this protein are carbohydrate based. So disaccharide, that means that they are based on 2 sugar units. And our intention with this project was to study exactly how all the hydrogen bonds between these sugar units and the protein look. How long are they? What directionality do they have? What direction are they pointing in? And could these be replaced in any way with other units than sugars in other drugs, in future drug candidates? And the conclusion was that no, drug design until now has been very wise to focus on not changing this disaccharide part of the ligands, but in exploiting and designing interactions with side pockets, joining things onto the sugar molecules rather than changing the sugar molecules themselves. And part of the adventure for us was to travel to many different neutron sources around the world. The ILL in Grenoble, FRM2 in Munich, Oak Ridge National Laboratory in Tennessee in the US, and so on. And one of the reasons that we started to do the project in the first place is that we were interested in becoming, in the potential of neutron crystallography and becoming potential future users of the European Spallation Source, which is being built in our backyard in Lund. I've been for many years involved with the Max Lab synchrotron and until recently Max 4, and the ESS, European Spallation Source, is being built right next door, and I was interested in the synergies between these 2 facilities. And so we are looking forward to the first neutrons being delivered to the NMX instrument at the ESS sometime in the 2020s.